In this video, we're going to continue talking about ratios. In the last video, we talked about a 3-to-1 ratio, but ratios can have more than two parts. Take another example, this one from the steel industry. To make steel, the main ingredient is called pig iron. And to make pig iron, 3 ingredients are needed. Iron ore, which has to be of a certain purity, coke, which is coal that's been heated to make it high carbon, and limestone, which is calcium carbonate. These 3 ingredients are processed in a blast furnace at a ratio of 2 tons of ore to 1 ton of coke to 1/2 ton of limestone to make 1 ton of pig iron. So we have a 2 to 1 to 1/2 ratio of ingredients. Now you'll find that ratios that contain fractional amounts like this one are often multiplied through by a constant to convert them to whole numbers. People like their ratios to be in whole numbers. They don't have to be, but they tend to be expressed this way. And of course, we already know we can multiply a ratio through by a constant as long as we multiply all parts of the ratio by the constant. In this case, multiplying the ratio 2 to 1 to 1/2 through by a constant of 2 would give you 2 times 2 to 2 times 1 to 2 times 1/2, which turns out as a ratio of 4 tons of ore to 2 tons of coke to 1 ton of limestone. So 2 times 2 is 4, 2 times 1 is 2, 2 times 1/2 is 1. As we covered in the last video, this ratio could be written as 4:2:1, 4 to 2 to 1, or it could be written 4/2/1 as a ratio of ore, coke, and limestone. It doesn't have to be in that order. We could have a 2 to 1 to 4 ratio of coke, limestone, and ore. So notice I reordered the ingredients when I reordered the ratio. And of course, there are numerous equivalent ways to write this. Let's look at example 9.3. If the pig iron mill has 6 tons of iron ore, how much coke and how much limestone will it need to use up all of the ore following a 4-ton to 2-ton to 1-ton ratio of ore, coke, and limestone? In example 9.3, there are 2 things we're trying to determine. So when faced with a problem like this, identify what the unknowns are. What are we trying to find? What we're trying to find is how much coke and how much limestone we need to add to 6 tons of iron ore at a ratio of 4 to 2 to 1 ore, coke, and limestone. So how much coke we need, I'm going to notate that with a C. So in mathematical problems, it just helps to use notation to shorten what you're doing. But being clear about what you're identifying as what is really, really important. So I'm going to call how much coke we need C, and I'm going to call how much limestone we need L. So that's like a cursive L. Now we have a ratio of 4 tons of iron to 2 tons of coke to 1 ton of limestone. To solve this problem, you don't want to do it all at once. What you want to do is break it up into 2 parts. We need to solve for C and we need to solve for L. So when we're considering C is going to be a number of tons of coke that we're going to need to add. What ratio does coke exist in with iron? Because the thing is the known here is that we have 6 tons of iron. So in order to find out how much coke we need, we can use the ratio 2 tons of coke to 4 tons of iron. That's a ratio that relates the amount of coke we need to the amount of iron we need. So you see, we're not including lime in this problem because we're not dealing with lime right now. We're dealing with the ratio of coke to iron. So we set this 2 to 4 ratio equal to the right-hand side. On the right-hand side, we're going to include the information that we know, which is that we have 6 tons of iron. We put that on the bottom because it's on the bottom on the left-hand side. And we would like to know for that many tons of iron, how much coke do we need? And that is what we're symbolizing with C. In order to solve this problem, we cross multiply. We're going to go 2 times 6 and 4 times C. On the left-hand side, we get 2 times 6, which is 12. Right-hand side, we get 4 times C. To solve for C, we have to divide by 4 in order to cancel out the 4 that is multiplied by C. Here we're going to get 4 over 4 is 1. Here we get 12 over 4 is 3. I'm going to write the C on the left-hand side, and we get C equals 3. So we need 3 tons of coke for 6 tons of iron ore. Now let's take the limestone part of this problem. So I'm going to use this script L, so that's like an italicized L. And what that is tons of lime. What is our ratio with iron? Well, we see that from our original ratio, 1 ton of lime goes with 4 tons of iron. Set that equal to another ratio, which is going to be our unknown amount of lime that should go with 6 tons of iron ore. Cross multiplying 6 times 1 and 4 times L, we get 6 equals 4L. To solve for the amount of lime we actually need, we need to divide by 4 in order to take care of that coefficient on L. These cancel and become 1. This simplifies to 3/2 or 1.5. So the amount of lime that you need for 6 tons of iron ore is 1.5 tons of lime for 6 tons of iron ore. Example 9.4 says, if the pig iron mill has 12 tons of iron ore, 3 tons of coke, and 2 tons of limestone, how much pig iron can it make? Which of the ingredients is the limiting factor? We know we need 4 tons of iron ore to 2 tons of coke to 1 ton of lime. And with that, we can make 1 ton of pig iron. This is from the description before we started these examples. A good way to solve this problem is to examine each of the ingredients in turn and to figure out how much of the others you would need to use up all of that ingredient. So let's start with the iron ore first. We have iron ore of 12 tons. With 4 tons of ore, we need 2 tons of coke to process. So that means we need half as much of the amount of iron ore in coke in order to process the iron ore. So to process 12 tons, we need half as much coke, which is 6 tons. But here's the problem. We don't have 6 tons of coke. We only have 3 tons of coke. So iron ore is not going to limit us. We have extra iron ore for the amount of coke that we have. So iron ore is not going to be a limiting factor. We have too much of it. Now let's take a look at the amount of coke we have. So the amount of coke we have is 3 tons. In order to use all of the coke, it would take double the amount of iron ore, which would be 3 times 2 is 6. We have 12 tons, so we have more than enough iron ore. We already figured that out. But looking at the coke to lime ratio, it's a 2-to-1 ratio of coke to lime. So we need half as much lime to process the coke because it's a 2-to-1 coke to lime ratio. So half of 3 is 1.5. And if you look at what we actually have, we have 2 tons of lime. So we have more than enough lime to take care of all this coke. We have more than enough iron ore to take care of all this coke. Coke is the limiting factor. So we've answered the second question. We still haven't answered the first question. How much pig iron can it make? It can make as much pig iron as 3 tons of coke can make. So how can we figure out how much that is? We can use yet another ratio. We can use the coke to pig iron ratio. And that ratio is 2-to-1. 2 tons of coke makes 1 ton of pig iron. So X in this case is going to be tons of pig iron. Set up the ratio 1 ton of pig iron I'm just going to call that 1 ton pig because we've done a lot of writing in this lesson so far. So the ratio is 1 ton of pig iron requires 2 tons of coke. We set that equivalent to our unknown amount of pig iron divided by our known 3 tons of coke that we actually have. Cross multiply. You get 3 equals 2x. Divide both sides by 2 in order to take care of the coefficient on x. These 2's cancel. 3 halves is 1.5. You could write it either way, but I'm going to write x equals 1.5. And that is 1.5 tons of pig iron is what you can get from 12 tons of iron ore, 3 tons of coke, and 2 tons of lime. The deal is you're going to have quite a bit of iron ore and lime left over for when the next shipment of coke arrives.